Hi, we are going to go through an example of Labrador Epistasis today. So these are actually like lab dogs. Many of you have seen those around. And the way the various coat colors come about have to do with epistasis. So black labs, which are right here, have no chocolate gene. Okay, so we have one gene. Big B gives you a black lab. And that is dominant to chocolate. So you'll also get a black lab if you end up having one big B and one little b. To be a chocolate lab, you have to have no black genes. It's recessive. So that's your little b right here. Now yellow is a little bit different. Yellow is on a totally separate gene, and it's considered epistatic, which means that if you have two little e's, no matter what's going on over here with your B gene that has to do with chocolate and black, this two little e's will trump that and make the particular puppy yellow. So any black lab you have must have at least one big E to show that they don't have the yellow gene. So if you've got one E or two E's, you're not going to be a yellow lab. But if you have two little E's, no matter what's going on with your chocolate and black gene, you will end up looking like a yellow lab. So now that you've got this information, I want you to go ahead and try to do problem number 1 on your worksheet. You might pause me right now, and once you've given it a shot yourself, you can come back and see how you did. Okay, you're back. Let's see how you did on problem number 1. So first of all, with problem number 1, you want to think about the fact that you have a black female and a black male lab that have mated and produced a bunch of black puppies. And the breeder is saying that these are purebred, meaning generation after generation they're producing black puppies. So from that information, we're going to assume a couple things. First of all, we're going to assume that a puppy out of this litter, this black female puppy, the black female original mother, is crossed with a yellow lab. So we're going to assume that black female is a big B. We're also going to assume, since generation after generation they haven't had any yellow labs, that on the other gene, she is a big E. Now, that's being crossed with a yellow lab. Now, the thing about a yellow lab is we don't know what they have on that first gene. They could have anything, and it would still look yellow because this yellow lab is going to have a little e on this gene. Now, when we think about their puppies, we know no matter what that this mom is going to give a big B to her kids because it's all she has to give. But, again, the male, yellow, we don't know what they're going to give on that first gene. So we're going to just leave that one blank because we're not sure what that is. And we know no matter what, the female is going to give a big E because that is all she has to give. So they're going to be a big E from her on this gene. And we know no matter what, the male is going to give a little E because that's all that he has to give. And we look at this, and no matter what even though we have an unknown at this allele right here, we don't know what allele goes in for this gene right here, we know no matter what we plug in here, all of their puppies are going to end up looking black. So we should have 100% black for problem number 1. Okay, let's go ahead and see how you did on problem number 2. Now, when you're thinking about this problem, we talk about a female black lab initially that's being crossed with a male chocolate lab. And we know that because the black lab Since black is dominant to chocolate, we know that this black lab has at least one big B. But it could be a big B, little b, or... Okay, let's take a look at problem number 2. In problem number 2, we are talking about a female black lab being mated with a male chocolate lab. Now, because it's a black lab, we know that they are a big B, have at least one copy of the big B allele. We do not know what the second allele is on that gene because black is dominant, so it could be heterozygous or homozygous. Now, we do know that she is not a yellow lab, so she has at least one big E. But again, because in order to have epistasis, you have to have both copies of the recessive allele. We don't know what's going on with that second gene. We're going to cross that with a chocolate lab. Now, chocolate labs we know they're little b, little b right here. Okay, since this is not a yellow lab, we know it's at least one big E, but we don't know what's going on in the second allele. And that really helps with the answer to this question, because again it says, can a black lab and a chocolate lab give birth to a yellow lab? Well, the answer to that is yes. If, for example, this original black lab was a carrier for that epistatic yellow lab gene, and if the chocolate lab was also a carrier for that epistatic yellow gene, and if, no matter what, because we can see right away, we know that this lab right here is going to give a little b. So we say, okay, that little b comes down for, say that little b comes down for sure. And we don't really know what this, we don't really know what's going to happen here, so we're going to have to put a line there. We don't know what's going to happen there. But if this is what happens right here, this little e and this little e both come down, then this pair of dogs can produce a yellow lab. Now, if you haven't already, give number 3 a shot and then come back and hear my solution. Okay, in number 3, we already knew the genotype of both of the parents. You have a big B, little b, and a big E, little e for both parents, because they're both heterozygous on both traits. So we're going to use a branch diagram. And remember, when you use branch diagrams, we look at one trait at a time. So let's start by looking at that black and chocolate gene. When you cross big B, 2 heterozygous, big B, little b's, you know that there is a 3/4 of a chance of having a black puppy and there's a 1/4 chance of having a chocolate puppy. I apologize for my terrible handwriting on this. Okay, so then you have, we have to look at the same thing with the epistatic gene. So with every single one of these situations, you have a 3/4 chance of having your normal color come through. And you have a 1/4 chance of having the yellow trump whatever the normal color is. Now this happens with your 1/4 group of chocolate labs. So out of that 1/4 that are likely to be chocolate labs, there's a 3/4 chance they get to keep that chocolate color. And there is a 1/4 chance that they'll end up having the yellow epistatic gene trump So what you do here is you say 3/4 times 3/4. That's a 9 out of 16 chance that you're going to get a black puppy. And 3/4 times 1/4, that's a 3 out of 16 chance that you'll get a yellow. And 1/4 times 3/4 is a 3 out of 16 chance that you'll get a chocolate puppy. And a 1/4 times 1/4 is a 1 out of 16 chance that you're going to get a yellow puppy. Now, since two of these are describing the same phenotype, you add them together, and in the end, you end up getting these two, a 3/16 and a 1/16, make 4 out of 16. So, really is 9 black to 3 chocolate to 4 yellow. And that 9 to 3 to 4 ratio is one of those ratios that when you see it, you can say, oh, that's epistasis. That's a clue for us. I hope this helped.